Om Sahana Bhavatu Sahanau Bhunaktu Saha Veeryam Karavavahai Tejasvinavati Tamastu Ma Vidvishavahai. Om Shanti Shanti Shanti. Om Samasta Jana Kalyani Niratam Karunamayam Namami Chinmayam Devam Satgurum Brahma Vidvaram Satgurum Brahma Vidvaram. So continuing with this topic of combinatorics, in Lilavati, Bhaskaracharya is discussing a few problems on combinatorics. So that day we saw how to find out NCR. So what does NCR mean? There are n objects. From that we are selecting R objects. So how many different possible ways are there? So if we are having 5 objects, out of which we are selecting 2, what will be the result? 5 factorial divided by 5 minus 2, that is 3 factorial into 2 factorial. So this is how we find out NCR, and then we had also seen NPR, that is when we are having n objects and this is an arrangement. Out of n, we are arranging r objects at a time. So if we are having 4 objects, out of which we are arranging 3 at a time. So how many different possible ways are there? So we have seen that examples of chocolate. So the answer would be 4 factorial upon n minus r factorial. So 4 minus 3 factorial. So this will be 4 factorial upon 1 factorial. Right? Now, if we have something like this, say for example, if we are having 2 objects, say let us take 2 objects like heads and t. This we usually take for tossing of coins, heads and tails. And there is only one position. So what can come here? Either it can be a heads or it can be a tails. So how many different possible ways are there? 1, 2 possible ways. Suppose there are 2 spaces. That means this one, here we are tossing 1 coin. So either it can be a heads or it can be a tails. Here we are tossing 2 coins. So how many possible ways are there? Either it can be, first coin can be a head, second also is a head, or first is a head, second is a tail. Any other possibility? Tail, heads, tails, tails. So there are 4 possible ways when we are tossing 2 coins, right? Here we are tossing 1 coin. Suppose we are tossing 3 coins. 3 coins. So how many different possible ways can be there? One can be H, H, H. Now here again we should take care that we are not missing something out. So maybe we can go think of that Lagu Guru, LG, right? So scan from the left, first H, below that you write a T, then whatever is there on the right side copy it down. Then you scan from the left side, first H you encounter, below that you write a T. What is that? H. Left side you will put an H. Very good. Below H, T, H, and then T, H, H, and then T, H, T, and then T, H, and then T. There is 1, 2, 3, 4, 5, 6, 7, 8. 8 possibilities. Can you see something interesting here? If I toss 4 coins, how many possibilities might be there? 16. So how did you guess the answer 16? 2 raised to 4. So So why 2 raised to 4? Because there are 2. That is, there are 2 possible outcomes. That is either heads or tails. There is no third way out. Right? So when we are having like this, when we are having either one option is heads, the other option is tails. And how many positions are there? 3 positions. So suppose the number of possibilities here is like, here it is 2, right? So 2 raised to how many positions are there? According to that, so number of positions, right? So here 1, so it is 2 raised to 1. Here it is 2 raised to 2. Here it is 2 raised to 3, and so on. What if we have, instead of h and t, we take some other things like, say, there are 3 possible outcomes, say for example. Or let us say, okay, let's start with three possible outcomes. So either we can get a 1 or 2 or 3. Right? And we are having one position. Only one position. So how many possible outcomes will be there here?
3.
1, 2, 3. That it can be 1, it can be 2, or it can be 3. So this is again here, instead of 2, this is 3 raised to 1. How many will be here? 3 raised to 2. Now we will have to check if we get 3 raised to 2. We have got 2 positions. So either it can be 1, 1. Let us start from the smallest to the largest. 1, 1, 1, 2, 1, 3. 2, 1, 2, 2, 2, 3. Same for 3, 1, 3, 2, 3, 3. Right? Here repetition is allowed. So we are arranging, so how will 1, 2, 3, 4, 5, 6, 7, 8, 9. So here it will be 3 raised to 2. So here if you look at this number, and if we can just think of something like this, expressing it in this form, a raised to n. A raised to n. Where what is a? A is whatever is the number of things here, and n, what is n? N is the number of positions here, like if we have 2 or 3 or 4. So according to that, so if we have, say, if we have to arrange something like say 4 things and the number of spaces are 2, so the total number of options would be 4 raised to 2, which will be 4 square, 16, right? 4, number of objects is 4, and here number of positions it is 2, so it will be, you can think of array 1, 1, 1, 2, 1, 3, 1, 4. Similarly, 2, 1, 2, 2, 2, 3, 2, 4, 3, 1, 3, 2. So starting from 1 there are 4, starting from 2 there are 4, 3, 4. So 4 into 4, 16. That will be 4 square. Right? So keeping this thing in mind, we can just look at one question discussed in Lilavati. This is your verse number, I think it is 112 in the printout that you have. 112. Can you just read out that verse? Anybody from the printout? 112. It is not 110 here in Kulbrook's book. It is 110. This one. These three. In the printout it is 112, 113, 114. So these three verses actually is giving the rules for calculating NPR.
छन्दश्चित्युत्तरे छन्दस्युपयोगस्यतत्त्विनाम् पुंसावहन भेदानौ खण्डमेरौ च शिल्पते वैदिकीरसवेदीयन्नोक्तं विस्तृतेऽभयात्.
So that is the rule. So basically we are dealing with a question like this. We will look at an example and the the procedure would be really clear. So the example that we are discussing here in Lilavati is the permutations of Gayatri meter. So So a Gayatri meter has total 24 syllables, and 24 syllables taking 6 at a time in every verse. So if we take 6 at a time, so then say quickly, my friend, how many possible changes of the verse are, and tell severally how many permutations are with 1, 2, 3, etc. long syllables. So what is meaning is, if we have 1, 2, 3, 4, 5, 6 places. 6 places. That is 24 divided into 4 lines. 6 into no, we are having 6 places. 24 divided by 4 is 6 places. So in every line we will have 6 places, and we have either a lagu or a guru syllable. So we can keep here lagus or gurus. So what he is saying is, if you take with 1 long syllable or 2 long syllables or 3 long syllables, how many different possible ways are there? So suppose we take 1 long syllable in a verse. So a long syllable can be here. It can also be here, right? It can also be here. It can also be here, here, here. So if you take 1 long syllable, if you take 1 long syllable, 6. So either it can be 1, 2, 3, 4, 5, 6. Any of these 6 places. So what we have here, we have 6 places, and from that we have to take 1. This is the other way of looking at it. Okay. Means this. So it will be, there will be 6 possible there would be 6 different ways of arranging a guru. Either it can be here, 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 or here. Suppose we have to place 2 gurus in these 6 places. 2 syllables have to be gurus. Rest everything have to be lagu. So how many would be there? 36. So this is 1, 2, 3, 4, 5, 6. Gurus can be like this, right? Rest everything is lagu. If we are having either, we can have guru over here and here, or here or here. So how many are there? 15. Now how can we get this answer 15? 6, C, 2. So which will be, out of 6, we are selecting 2 positions. Out of 6, we are selecting 2 positions for G. So it will be 6 factorial divided by 6 minus 2 into 2 factorial. So this will be 6 factorial divided by 4 factorial into 2 factorial. So if we simplify this, 6 into 5 into 4 factorial divided by 4 factorial into 2 into 1. So this we can cancel, and this will become 6. So 5 3s are 15. As we can see here, there are 15 different possible ways for this. What if we choose 3 long syllables? 63. So how many possible ways are there? 6, C, 3. That is, out of 6 places, we select 3 places for gurus. Out of 6 places, we select 3 for gurus. So this will be 6 factorial upon 6 minus 3, 3 factorial, and 3 factorial, n minus r factorial into r factorial. So this will be 6 into 5 into 4 into 3 factorial divided by 3 factorial into 3 into 2. That will be 20. So that is 20. So like that, if we have to take 4 gurus, it will be 15. And we had seen this in that presentation. That is 6C2 and 6C4. This will be 6 factorial upon 6 minus 2 factorial into 2 factorial, and this will be 6 factorial upon 6 minus 4 factorial into 4 factorial. So we can see these two are same, these two are same, numerator is the same. So 6C2 as well as 6C4 both are same. Right now. So for 4 gurus also we have 15. Similarly, for 5 gurus we have 6. For 6 gurus we have 1. Right? So what do we have in total? This is our total. With 0 gurus, that is with all laghus we have 1. With 1 guru we have 6. With 2 gurus we have 15. With 3 gurus 20. 4 gurus 15. 5 gurus 6. 6 gurus 1. So total how many different? So if we have to construct a verse with 6 syllables and we have 2 options, we have only 2 syllables, either a guru or a laghu. So how many different possible verses can be constructed, or in how many different possible ways? One possible way is we take 0 gurus, that is we construct a verse with all laghus, so we have only one way. If we construct a verse with 1 guru in 6 different places, so we have 6 ways. Yes. And if we take 2 gurus in different places, we arrange, we have 15 ways. Similarly 20, 4 gurus, 5 gurus, 6 gurus, and then we get the total as 64. So now this is 2 raised to 6. Why? Because earlier we had seen this example of heads and tails. So there we had 3 positions, 1, 2, 3, and we had heads as well as tails. So the answer that we got was 2 raised to 3. Right? So here similarly we can think of guru as well as laghu, and then we are having 6 places. So this will be 2 raised to 6. Right? 2 raised to 6 different ways are there. Now he gives an example of, if you go back to the example, how many possible ways there to construct a verse, and for a verse. So since the Gayatri Chanda has 6 syllables, the number 1 to 6. So this is the procedure that he does not explain NCR or NPR or anything. This is the procedure that he gives for finding out the result. He says, since there are 6 syllables, 1 to 6 has to be arranged in the reverse order, 6, 5, 4, 3, 2, 1, and in the increasing order, 1, 2, 3, 4, 5, 6. Okay? Those who are working out problems, can you have your attention here? Yes? Just look here. So here, all the syllables 6 to 1 are arranged in the reverse order and here in the ascending order. So what he is saying is, if you want to find out the number of different ways with one long syllable, what you have to do is, in this arrangement you take the first one, 6 by 1. That is 6. 6 divided by 1 is 6. Suppose we want to find the number of changes with two long syllables. So 2 gurus. So we have to take the same table, the first 2 here and first 2 of the upper part and first 2 of the lower part. So 6 into 5 divided by 1 into 2, which is nothing but 30 divided by 2 is 15. And if we have to find the changes with 3 long syllables, we have to do 6 into 5 into 4 upon 1 into 2 into 3. 5 4s are 20. So this is the procedure that is suggested in Lilavati. So like this we keep on doing. But only for this particular case, it won't be like 0 by 0. It will be 1. Our 0 factorial. Or if you take the example of out of 6, 0. So 6 C 0. That will be 6 factorial upon 6 minus 0 factorial into 0 factorial. So this will be into 6 minus 0 factorial into 0 factorial. So 6 minus 0 is 6. So 6 factorial upon 6 factorial is 1. 0 factorial here we consider as 1. So he is not talking about factorial thing, but this is the procedure that he suggests. And he gives another example. He gives the example of taking 6 flavors. The 6 flavors. What are the? Okay, it's given here. 6 flavors: sweet, pungent, astringent, sour, salt, and bitter. What is that in Sanskrit? 6 rasas. So with 6 rasas, if you have to make a particular a particular eatable. So out of using that 6 rasas, how many different ways are possible? How many are possible? Think once more. It's not compulsory that we have to use all the 6. We can use 1, we can use 2, we can use 3, 4, 5 or 6. It's up to us. So if we think of comparing this, if we go to the previous example here we could take 0 gurus, right? But here in this case we can't take 0 flavors. At least one we have to take. So that one option is gone. So what will remain? 2 raised to 6 is 64. But in that 0, that option is gone. One option is gone. So minus 1. So that will be 63. And this we can see if we write down the powers of 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3. So 2 raised to 1 is 1, this is 2, this is 4, this is 8. We keep adding this 1. 1 plus 2, 3. 1 plus 2 plus 4 is 7. 1 plus 2 plus 4 plus 8 is 15. We can see that this is 1 less, this is of course 1. This is 4 minus 1, this is 8 minus 1, this is 16 minus 1 and so on. This will be, next will be 32 minus 1, next will be 64 minus 1. So here, what is the thing? If we add all these things, if we add 2 raised to 0, 2 raised to 1, 2 square, 2 cube and up to say 2 raised to n minus 1, up to 2 raised to n minus 1, the total that we will be getting is, can you tell me, 2 raised to n minus 1. So if we take the total, that will be the value of 2 raised to n and minus 1, that will be this total if we add all these things. So this was the question that I think sir had asked in the first class, where we have to, there was a man who was thought, they thought he was a madman, he was a thief, right? It was thought, yeah, but he was a mathematician, so he was asked to prove. So he was given 127 coins, 127 coins, and he was asked to make certain number of weights. And if we tell any number, say I want to make the weight of 56, using those particular weights, he should be able to make 56 out of it. So he has to make bags of that. So in one bag, he'll put 1, in another bag he'll put 2 coins, in another bag he'll put 4, 8, 16, 32, 64. If we add all these things, the next power is 128. This you will get as, if you add all these things, you will get 127. So if he has 1, 2, 3, 4, 5, 6, 7, he makes 7 bags of this particular thing. You take any number, you can add. So if you are to add 56, we can take 32 plus 16 will be 48 and plus 8 will be 56. That number we get. Any number we want to take under 127, up to 127 we can make using these things, right? So we just need to have these particular weights. 7 weights and we can weigh anything up to integer values up to 127. So this we can get. So this is a question that he asked in verse 114. I think in your printout will be verse 116. Verse number 116. But the procedure is different. He does not talk about NCR or NPR. He talks about arranging numbers in the ascending or descending order, ascending and descending order. Anyways, we'll look at one more question. Here, verse number 114. I think in your printout it would be verse number 116. It's in a pleasant, spacious, elegant edifice with 8 doors, constructed by a skillful architect as a palace for the lord of the land. Tell me the permutations of apertures with doors or windows, whatever taken 1, 2, 3, etc. Say mathematician, how many are the different combinations in the composition? Okay, that is the second part of the question. That is with these flavors he is asking. This is the second part, this is the first part. So here we have a building. Suppose we have a palace, something like this. There are 8 doors. There are 8 doors and constructed by taking 1, 2, 3 at a time. Okay, what he means is, suppose one door is open. How many different possible ways are there? One, this can be opened, this can be opened, this. So there are 8 possible ways over there. If one door is open, if 2 doors are open, how many possible ways are there? So 8 into 7 divided by 1 into 2. Right? So if we take our 8C2, this will be 8 into 7 into 6 into 5 into 4 into 3 into 2 divided by 8 minus 2 factorial upon 2 factorial. So this would be 6 factorial will go directly and 2. 7 4 are 28. That is the same thing that we get over there. So 8C2, so that is one way is 8C1, the other way is 8C2, the third way is 8C3, the fourth way is 8C4. If 5 doors are open, it is 8C5, 8C6 and 8C7, and if all the doors are open, 8C8. If all the doors are open. But what if all the doors are closed? 8C0. Right? So these are the total possibilities. So 8C0 would be only one possibility when all the doors are closed. 8C8 also only one possibility is when all the doors are open. Here we have 8 and 8C1 and 8C7, that should be same. So 8, this we got as 7 4 are 28, so this is also 28. 8C3, let us do using Bhaskara's method, 8 into 7 into 6 divided by 1 into 2 into 3. So 8 7s are 56. 8C4 would be, again you do it into 5 and into 4 here. So 4 2s are, so 14 into 5, that will be 70. 8C5 will be 56. Just see what you are getting when you add all these things. Yes? 28, 28. So that is 56. So 56 into 3 plus 70. So 168, 238, 238 plus 16 plus 2. So 240, 256. Right. Now here all the doors, if we ignore this option, instead of that door, suppose this was 8 different objects, 8 different eatables like ingredients. So we will have to ignore this particular thing. So we will get 2 raised to 8 minus 1. It will be 256 minus 1, that is 255. So this is the procedure that he gives. Now we'll look at one more thing. I don't have a presentation for that, but we'll just look at it. It talks about a bit about geometric progression and gives the formula for geometric progression. So geometric progression, as we had seen, if we have something like 1, 3, 9, 27, where the ratio between two consecutive numbers, it is same. If the ratio is same, then we call this as a geometric progression, GB. There is another interesting construction that we find today in geometric progression. So if this is the diameter, and if you take this as 1 and you take this length as 9, you draw a perpendicular to the semicircle, so this length would be 3. So we had seen something like this today, where 3 square equals this into this. When you have a right angle triangle like this, right? This was the height, and this square equals this multiplied by this. That is the same thing we can see here also in GB. So if we have a diameter of 10 and you have taken 2 here and 8 here, so 2 and 8, so 2 into 8 is 16. So this has to be square root of 16. So this length would be 4. So any number if we take, if you want to find this 4 is called the geometric mean. Actually, for average, there are different terms for average that we use. And when we discuss different types of averages, arithmetic mean, median and mode, when we go to higher classes. Yesterday, the thing that we discussed was average. When we talk about arithmetic mean. Generally, that's the first kind of average that we learn in schools. That is, if we are having 2, 4, 6, 8, what is the average of 2 and 8? That is, what is the arithmetic mean of 2 and 8? Means what comes in between 2 and 8. So 8 plus 2 divided by 2. So 10 divided by 2, 5. So exactly 5 comes in between here. If I have to take the arithmetic mean of 6 and 2, it will be 6 plus 2. 8 divided by 2 will be 4. That will be the arithmetic mean. And here we have, if I have to find the geometric mean of two different things, so I have to take 9 into 1. 9 and square root of that will be the geometric mean. Why does that happen? That happens because this is my A and the next number is A multiplied by a ratio. Third number is A multiplied by R square. The same thing we are multiplying by the ratio, and this number we are multiplying by the ratio again, right? So the first number, or if I take this number 9, this is AR square divided by the earlier number is AR. If I cancel, I get R. If I take this number, or if I take AR divided by A, I get R. And if I take AR square divided by AR square multiplied by A, 9 into 1 multiplied by A will be A square R square. What is the geometric mean of that? That is the square root of AR square, which will be AR. So geometric mean means, like arithmetic mean, in the geometric progression, what comes in between two particular terms will be the geometric mean. So to find out using geometrical construction also it is easy. If I have to find the geometric mean of, say, suppose 3 and 7, I just have to construct a diameter with 10 and draw a perpendicular like this. If I measure this, whatever length I am getting here, that is 7 into 3, 21. Square root of 21 would be the length here. This length. So we can take any number if we have to find the geometric mean of any two numbers. And the formula that he gives here for geometric, what is that? what is the words for geometric? What is the words for progression? Progression is just. That is just before. That is after combination. Yes. Yes, 1, 3, 0. We did arithmetic progression yesterday, and this one, I think this is the words for geometric progression, 130. Before that it's arithmetic progression, so it's 130, and yeah, in this words, it gives the formula for that. That is, if we have to find the sum of a series of an arithmetic progression. So this is the arithmetic progression: a plus r square, a plus r cube, like that. If you go up to a and r raised to n. So it's the same thing. I mean, we can write in two different ways: a into r raised to n minus 1 upon r minus 1, or both these things. If r is less than 1, so we'll get a if r is less than 1, so we'll get a negative here, and we'll get a negative here. So it will be nullified. So the answer will be positive here. So this is the formula that he gives. But in the problem, I have got it out. So we can clarify. Not these two problems. The last one. For geometric progression, he gives one udaharanam. So here we have our a as 2, r as 2, and n is 30. So we have to find the sum of first 30 terms. So basically, we just substitute the value for a. A is 2, r is also 2, and n is 30. Right? Number of terms is 30. Minus 1 divided by r is 2. So 2 minus 1, this will be 1. So 2 times 2 raised to 30 minus 1. So we will have to find out what is 2 raised to 30 and then get the answer. But does he give any particular way for squaring this particular? I mean, how to find powers of 30?
Now, when verses are found in Chinmaya Shastra, there will be two main categories: Varna Vritta and Matra Vritta. Vrittas classified on the basis of the syllables or aksharas in a vritta pada are called as Varna Vrittas. And the verses classified based on the matras in a vritta pada are called as Matra Vritta. Now, taking the first category, Varna Vritta, again they are classified on the nature of the four padas. If all the four padas are similar, that type of vrittas are called as samavritta. If alternate padas are similar, then ardha samavritta. If all the four padas are different, then those are called vishamavritta. Now let us restrict ourselves to samavritta. In samavritta, if there is only one akshara in one pada, that is ukka chanda. Ukta, Atyukta, Madhya, Pratishtha, Supratishtha, it goes on. So, the last one are up to 28 syllables. It is called by the name 28 and above Dandakas. 28 and above are called Dandakas. There is no limit for it. If 28 aksharas or 28 varnas and above in a vrittapada, that sort of vritta is called as Dandaka vrittas. Now, if there are 28 aksharas or syllables in the vrittapada, samavritta, if we want to know the number of ardha samavritta in a dandaka having 28, then it will be, instead of 2 raised to 28, it will be 2 raised to 56. If a dandaka vritta having 28 syllables in a vrittapada, and if it is a vishama vritta, then those numbers, possible numbers will be 2 raised to how much? Double 56. It will be 112. 2 raised to 112. Now, to imagine 2 raised to 28, 2 raised to 56, and 2 raised to 112, how big it is? There is a Danta Katha. Actually, it is said as it is in the history. There was a Raja or King or Naresh in Sindh Pranta. Sindh Naresh. There was a mathematician by name Shesha. Shesha invented a play, that is chessboard. The chessboard, the play played on chessboard, that is Chaduranga. Chaduranga. He invented it and he showed to the king. King was very delighted. He said, "You ask me anything, I will give you. I am very happy." So he was boasting himself of the kosha, that I am so big king. And that mathematician, it touched his pride. That Shesha, "No, I don't want anything. I want some wheat corns. Some wheat corns." "Why do you want wheat corns? I am ready to give you anything." No, I want only wheat corns. In such a way that one wheat corn on the first set, one wheat corn on the first set, 2 wheat corns on the second, next 4 wheat corns, 1, 2, 4, 8, 16, 32, 64. So, doubling the number of corns in each cell. So, what will be the number of corns in the 64? It is 2 raised to 63. Because in the first 2 raised to 0. So, instead of starting from 1, they start from 2 raised to 0 and last will be 2 raised to 63. So, Raja ordered his Koshadhikari, Bhandari, give him wheat corns. He is a madman, he don't know what to ask before a king. I am king here to give anything to him, but he is not ready. It is his fate, give him the corns, he has said. 1 week elapsed, nothing was happened. 2 weeks, 1 month has elapsed. Then Shesha came to the king. "Oh Lord, you have not stick on to your words. I have asked you to give some corns, but not yet fulfilled." Then he called his Bhandari. "What is the case?" Then Bhandari said, No, the mathematician is a great man." So, he counted a sale, that is Adaka. So, the number of corns he asked, if it is calculated, how much it will be, it works out to such a huge quantity that if the whole earth without water, if the whole earth is considered as a field, if 2 crops per year are grown on the whole surface of earth, it will take 200 years to grow so many crops, so many corns. Then Raja was ashamed of his proud words. So, Shesha. So, 2 raised to 63 is that one. I will send you to moon. Only your job is to cut the paper into for the 50 times. You tear the paper as I say. ನಾನು ಹೇಳಿದಂಗೆ ನೀವು 50 ಸಲ ಒಂದು ಪೇಪರ್ ಹರಿದು ಸಾಕು, ನಾನು ನಿಮಗೆ ಚಂದ್ರ ಮೇಲೆ ಕಳಿಸೋ ಜವಾಬ್ದಾರಿ ನಾನು. How to tear a paper? Take a paper. Now this is a paper. Fold once. You fold once, tear it. This is one side. Next, join the both. Next, again fold it. Then tear it. This is second time. Like this, if you tear for 50 times, then what happens? If you keep one paper above the above, that paper itself will reach moon. So you have to imagine such big things. Coming to here again. Now we want to calculate 2 raised to n, that is 2 raised to 30. How to calculate 2 raised to 30? In case of calculating the number of vrittas, possible vrittas, Pingala gives a method. Rupe Shunyam. The original sutra is only 2 words. Rupe Shunyam. Virardhe. Rupe Shunyam. I will explain the content of it. Right. Now forget about Rupe Shunyam and the Pingala Sutra. Based on this Pingala Sutra, the same method in the modern form. Now it is explained here. There are Vargakarana and Gunana. Gunana and Vargakarana. Guna-Vargaja-Tantra. It is developed from Gunakara and Vargakarana. That's why it is called as Guna-Vargaja-Tantra. The process of Guna-Vargaja-Tantra stated in a concise form is found in the rules given in the summation of a GP in almost all Hindu mathematical works. The rule given by Narayana Pandita in this connection is as follows. I have selected different mathematicians to the same rule stated since Pingala. It is stated by Chaturveda Prutudika Swami, that is commentator of Brahmagupta. Now, Vishame pade virupe gunaha same ardhe krite kritischandya Guna-Varga-Phalam vekam veka-gunaptam mukha-hatam gaditam. There are 2 formulas stated here. First one to find r raised to n, then second formula to find s. Now, the formula stated to find r raised to n is Guna-Vargaja-Tantra. By an example, we shall try to know by an example. Now, I want to find r raised to n. Somebody gives 6 rupees on the first day and on each subsequent day, increasing by 3 times the previous day. What is the total amount given by him in 10 days? This is the formula. Now, can anybody tell me to have an agreement with me for 15 days? For 15 days. I will give you daily 1000 rupees. You should give me on first day 1 rupee. Next day 2 rupees. Next 4 rupees. So for 15 days I will give 1000 rupees on each day. What you have to do? You have to give 1 rupee on the first day. Next 2 rupee on the second day. Shall we have an agreement? No, only 1 rupee on the first day, 2 rupee on the second day. Reverse is possible. Now, first term A is equal to 60. That R, that is common ratio is 6. Number of terms is 10 days. Somebody gives 6 rupees on the first day and on each subsequent day increasing by 3 times the previous day. What is the total amount given by him? 10 days. So here n is equal to 10. That is common ratio R is equal to 3 and A is equal to 6. At the first instant we will find R raised to n. Then in the second part we find S. How to find R raised to 10? This Guna-Vargaja-Tantra involves the laws of indices. Laws of indices. Now, n is 10. Take it well. 10 is an even number. 10 is an even number. Divide it by 2. Divide it by 2. So the result operand is 5. Next, take that 5. It is an odd number. It cannot be divided by 2. So, subtract 1. You will get 4. Next, take that 4. It is even number. It can be divided by 2. The result is 2. Take again 2. Divide by 2. You 1. 1, take 1. Deduct 1, 0. I think these 2 columns you have followed. While you are dividing by 2, write it as a square. When you subtract, write it as multiply. Then this is varga, this is gunana, varga, varga, gunana. Rupe shunyam. That means when you subtract 1, you denote it by shunya. Vir ardhe. When you divide by 2, you denote by the number 2. Now we have to take out the process. We have operand 0, the work is over. What we have to do? We have written down the mathematical operations which is to be carried out on what? Which is to be carried out on the common ratio. Common ratio is 3. What we have to do? Multiply this 3, you keep the common ratio 3. Take its square, it will be 9. Multiply 9 square, again multiply this result, 9 square is 81. You take 81 here, what we have to do? Multiply by 3, 243. Take 243 here, what to be done? Square. So, this will be 3 raised to 10. बताएगा मालूम नहीं हुआ? This 10 is the index. R raised to n is 10. So n is equal to 10. वो even है क्या odd है उसको जो है ना 2 से डिवाइड करते जाना. अगर even है तो 2 से डिवाइड हो जाता है. If it is डिवाइड हो गया बोले तो उसको स्क्वायर बोल के लिखना. अगर डिवाइड नहीं हो गए तो उसको एक उसमें एक निकाल देना, एक निकाल के जो है वहां पर मल्टीप्लाई करो बोल के लिख देना और नीचे से शुरू करना। इन द रिवर्स वे फर्स्ट राइट डाउन द कॉमन रेशियो 3. That is 1 into 3. What we have to do next? Take the square of the result in the first step. 3 square 9 हो गया. Next what we have to do? What we have to carry out? You have to carry out square of the result in the previous step. 9 square 81. What we have to do? Next step multiply. किसको मल्टीप्लाई करना है ना? ए रिजल्ट किससे मल्टीप्लाई करना है? वो गुणोत्तर श्रेणी में जो रेशियो है, कॉमन रेशियो, उससे करना है 243. Again what we have to do? Take the square of 243. You will get the result, that is 2 raised to that 3 raised to 10. Next. Now the formula is S is equal to A into R raised to N minus 1 by R minus 1. Here A is equal to 6, R raised to 10 is equal to this result obtained minus 1 by R minus 1, 3 minus 1. This is the answer required. Any questions? समझ गए? This is Guna-Vargaja-Tantra was used to calculate the nth power of any number. Earlier it was used to calculate the number of possible vrittas. That's why it was included in Chandaschiti. Chandaschiti means the chiti formed by, chiti means a pyramid. For when Ukta only one possibility, only 2 possibilities are there. For Atyukta 4, so 2, 4, 8, it is chiti, chandas chiti, depending on the number of syllables. So actually it is now it was included in GP, but this classification is not correct. This has to be included in Ankapash. Why it was included in Vijaganita? Because of this Guna-Vargaja-Tantra stated in GP, it was included. Chandaschiti was earlier included in progression chapter. That the Chandaschiti is to be included in Ankapash. Next.
In this Rupesh Shunyam you said, no? So there we have to write that Shunyam.
Based on this, it is formed that if you want to details, go to the other articles.
We can go to it.
Yeah, it is in Mangalore article. That is Chanda Shastra. You leave it. Lilavati. 130. Now, while explaining, there was no mathematical error, but एकादेकोत्तरतः पदम ऊर्ध्व अधः यतः स्थाप्य प्रतिमूलघ्नं प्रतिमूलघ्नेन भाजितं सारम्. यहाँ पर भास्कराचार्य ने व्यस्ताभाज्या वर्स नंबर 130 बता दीजिए. इससे पहले 112 No, verse number 112. एकादेकोत्तरतः एकादि एकोत्तरतः. What is the krama? अंकानां वामगोततिः. एकादि एकोत्तरतः. Then Vesta means in the reverse order. Bhajya, that is x 6 by 1, 5 by 2, 4 by 3, 3 by 2, 3 by 4, 3 by 4, 3 by 4, 2 by 5, 1 by 6. Now there are 6 fractions. There are 6 fractions. एकादेकोत्तरतः अंका व्यस्ता भाज्या क्रमस्थितिः परः पूर्वेण संगुण्य. परः next one परः पूर्वेण संगुण्य. That is 5 by 2 is to be multiplied by 6 by 1. Next अगर हमको ये होना है बोले तो 4 by 3 is to be multiplied by 5 by 2 and 6 by 1. This is the content. Mathematically there is no difference. But while taking the meaning, what is exactly said in the verse? Paraha purvena sangunya tatoparena tena cha. ऐसा ही करना आगे करना है. So these are the intricacies of the Sanskrit language. Next. One more thing. Have you clarified permutation and combinations and taking permutation of Guru and Ladhu? It is equal to value of the combination but not combination. Now, उसका temporary temporary presentation ये मात्रा है और ये चीज है. Now, in Ukta Chandas, there is only one varna or one akshara in one quarter of the verse. So, how many possibilities are there? The only one akshara may be a Guru akshara or a Laghu akshara. There are only 2 possibilities. That is, Guru akshara denoted by S and Laghu akshara denoted by I. So, number of possibilities 1 and 1, then totally 2. That is 2 raised to 1. The first you have understood, I think. Next, coming to Atyukta. In Atyukta, there will be 2 aksharas in each pada, in each vritta pada. Both the letters may be Guru. The first letter may be Laghu and the second Guru. The first may be Guru and the second Laghu. Both may be Laghu. This is one variation, 2 variations, 1 variation, totally 4 variations. Okay? Be attentive. Next, in Madhya Chanda. In Madhya Chanda, there will be 3 aksharas in each vrittapada. All of them may be Guru, that is 1 variation. First Laghu, that is the remaining Guru. Middle one Laghu, or at the end it may be Laghu. That means 3 variations. Similarly, other 3 variations and last one. So 1 variation, 3 variation, 3 variation, 1 variation, totally 8 variations. That is 2 raised to 3. Madhya Chanda. Next, take Pratishtha. Pratishtha consists of 4 letters. Yes, that is all the 4 gurus. Now first one Lagu, remaining guru. Second one Lagu, remaining guru. Third one Lagu, remaining guru. Last one Lagu, remaining guru. So there are 4 variations. If we consider 2 Lagu and 2 guru, there will be 6 variations. 3 Lagu, 4 variations. All Lagu, 1 variation. Total works out to 60. That is 2 raised to 4. 2 raised to number of aksharas or number of letters. Now if there are 6, then this will be the chart. Now here we have given their serial number also. We have given their serial. There will be totally 64 variations, and they are arranged according to a specific rule. Here, a specific rule. Arrangement. Arrangement with what? Arrangement means permutations. Regarding combinations, it is selection. 2 terms you have to remember. Arrangement means permutations and selection means combinations. Now these are all permutations, not combinations. These are all because we are arranging them with respect to their position. Now, if we arrange 6 arrangement of 6 things of 2 categories, arranging 6 things of 2 categories, allowing repetition of any category any number of times. There are 2 categories, Lagu and Guru, allowing the repetition of any category any number of times. That means one category may be repeated all the 6 times, one category may be only once, one category may be twice. So other category will be total number minus which repeats itself. That means there are 6 letters. Let us consider here. Out of 6, Guru repeats for 4 times and Lagu repeats itself for twice. So repetition is R, number of repetitions is R, then other will be N minus R. टोटली अगर n अक्षर रहे तो 2 कैटेगरी का एक R बार आता है, तो दूसरा कितना बार आना चाहिए? n माइनस R बार आना चाहिए. ठीक है. अगर 6 अक्षर है, 6 अक्षर है, उसमें अगर 2 लघु है बोले तो 4 गुरु रहेगा. अगर 3 लघु है बोले तो 3 गुरु रहेगा. अगर 4 लघु है बोले तो 2 गुरु रहेगा. और अगर 5 लघु है बोले तो 1 ही गुरु रहेगा. अगर 6 लघु है बोले तो 0 गुरु रहेगा. So these are combinations. Permutation of n things. Permutation of n things of different category, each different. Permutation of n different things taken all at a time. Permutation of n things taken all at a time is equal to n p n is equal to factorial r. ठीक है? n p n is equal to factorial r. n p n is equal to factorial n. n p n is equal to factorial n. Among n, if there are 2 categories, one category repeats for r times and other category repeats for n minus r times, then that number of permutations will be equal to npn, where there are 2 categories and one category repeats for r times and other category repeats for n minus r times. This is the equation. This is nothing but mathematically it is NCR. मालूम हो गया? अगर NPN, that is permutation of n things taken all at a time, in which all are not different. There are two categories. One category repeats itself r times, other category repeats itself n minus r times. Then what it works out to factorial n by factorial r into factorial n minus r. Mathematically, numerically it is equal to NCR. That is equal to combination of n things taken r at a time. It is numerically equal to that one, but concepts are different. That means, take for example 2 into 2. 2 into 2 is equal to 4. Multiplication. This is also equal to 2 raised to 2. 2 into 3 is equal to 6. It is not equal to 3 square. समझ गए? Now if 2 is the coefficient and if this 2 is the variable, 2 into 2 will be 4, but the 2 square is also 4, a particular case. मगर यहाँ पर 2 into 3 is 6, it is not equal to 3 square. ऐसा 2 उसमें क्या है? 2 और 2 3 एक ही नहीं है. वैसा जो है ना, there will be conceptual differences. उसका वैल्यू उतना ही है, 2 स्क्वायर भी उतना है, 2 into 2 भी उतना है, मगर जो है ना उसका दोनों का अलग अलग. वैसा ही यहाँ पर अगर number of permutations is equal to number of combinations, it is not the number of combinations. ठीक है? In case of षड्रसा, there is no arrangement. वो कौन सा भी पहले डालो, कौन सा भी ऊपर है मधुलात्री, खारा है मधुलात्री, ये लगता सब होता है. While preparing chemicals, it is combination, it is not permutation. षड्रसा खाना बनाते वक्त जो है ना, गुड़ पहले डाले तो क्या होने का है, उनसे डाले बाद में निर्णय ना कर देते. It doesn't make mathematical, but maybe some taste may be different, but mathematically it doesn't make any difference. So there it is combinations. कहाँ पर combination है, कहाँ पर permutation है, इसके बारे में ध्यान देना होगा. रिजल्ट एक ही रहे तो भी conceptual difference, कल्पना के difference रहता है, उस वास्ते बहुत ध्यान से देखना चाहिए.